Okay, part 2, we're dealing with reflections, and we'll start off with reflection in the x-axis. So the equation transformation, if I have f of x, what happens when I reflect it in the x-axis, you get negative f of x. Okay, and see how this is outside the function? That means it's changing the whole function, therefore you're affecting the y value or the y coordinate. Okay, so in my head, my logic over here is it's outside the function, therefore I'm affecting the y value. And I will show you guys this in action. This is my original function. Let's just call this f of x. It doesn't matter what the actual equation is. If I were to reflect it in the x-axis, the x-axis is over here, right? All I'm doing is pretending like there's a mirror and flipping it across here. So it will give you something that looks like this. For instance, this coordinate here, if I were to reflect it, well, what it becomes is it becomes 9, -3, okay? And that has, you can see that it's the y value changing when I reflect it in the x-axis. Now, if I have a reflection in the y-axis, what we're doing is, okay, we're reflecting across the y-axis, so you're changing the x values, therefore that occurs inside the function. So inside, and then we have our x value is changing. So once again, I'll share screen to show this in action. So get rid of these two coordinates. If I'm reflecting in the y-axis, you're flipping across this y-axis over here. Imagine there's a mirror there, and what happens if you flip across? Well, you get something like this, and you can see that it's occurring inside the function. I'm replacing the x with negative x. And so if I have the coordinate 9, 3, well, what do you think the coordinate would be if I were to reflect it in the y-axis? Well, it will affect the x value, right? So it becomes -9, 3. And if I label it, you can see that that's just the case over here. Okay, you've changed the x value because you're reflecting in the y-axis. Okay, now let's move on to dilations from the x-axis. Okay, so first step, you affect the y value or y coordinate. And obviously, every time you're affecting the y value or coordinate, that's the outside the function. So, for instance, if I have something that's like dilate a factor of 2 from the x-axis, what I get is f of x becomes 2f of x. Okay, so now you might be thinking, oh, how does it affect the y value or y coordinate? If I share screen again, okay, let's look at this graph over here. We have just a normal parabola, and I were to apply the transformation f of x, it turns into 2f of x, so the function of x squared becomes 2x squared. Now my coordinate 2, 4, I've changed the y value and I've multiplied it by 2. So obviously, if you look over here, our 2, 4 in the original function becomes 2, 8. And this happens because you're dilating from the x-axis or parallel to the y-axis. So what you're doing is you've kept the x-axis stable, and then you stretch the y-axis. And along with you stretching the axis that the graph lies on, you've also stretched the graph as well. So that's why the y value stretches along with the dilation. Okay, so let's go through dilations from the y-axis now. So we're dealing with the y-axis, so this time it's opposite from the x-axis.
It means that you're keeping the y-axis the same, but you're applying a stretch or a shrink to the x-axis.
Therefore, we're obviously affecting the x value. And every time we affect the x value, this occurs inside the function, okay? So if I were to give you guys an example, f of x, so I'm doing an equation transformation, f of x becomes f of 2x. What do you think this transformation is? Some of you guys may be tempted to say, dilate a factor of 2 from the y-axis. And if you said this, you are wrong, angry face. Okay, because remember, we're dealing with the inside function, so it's slightly different this time. The correct answer is dilate a factor of half from the y-axis. Because from our equation transformation, you can see that it's a 2, right? But since it's inside the function, we have to take the reciprocal. Okay, so that means flipping it. So for instance, if I have this transformation goes from f of x to 2 over 3x, well, what the actual word transformation would be dilate, not 2 over 3, a factor of 3 over 2. You flip it from the y-axis. And every time you flip it, this is what we call a reciprocal, okay? And we know that the coordinate, the x coordinate changes because of this dilation, right? So the coordinate, this is a very important point. Make sure you understand this. The coordinates change according to the word transformations. So every time we have something like this up here, f of x turns into the f of 2x. This has an effect on the equation, the function of the graph that we're sketching. So it has a direct impact on the actual function, whereas every single time we're doing coordinate changes, we relate it to the word transformation. And I'll show you this when I share screen. So we have a function here, x squared, the same one as before. Now this time, once again, we're doing the transformation where it's f of x turns into f bracket 2x. So obviously what you're doing is you're replacing x with 2x, okay? So that becomes 2x bracket squared. Now the dilation, the word transformation is dilate a factor of half from the y-axis. And since we know that this has an effect on the x values, therefore, at the point 2, 4 on the original function, the red is the original function, it will become 1, 4, okay, where you're changing the x value by timesing it by a half and the y value stays the same. And this makes sense because what we're doing here is we're keeping the y-axis is the same, therefore the y coordinates are the same. And what we're doing is we're shrinking the x-axis, therefore it has a change here. And this is the dilation of a factor of 2 from the y-axis, okay?